Hey, we're at week 13. Set 1, SWYK 2. Why is that appearing on my screen? Okay. Basic question at the beginning of this. Now, you'll notice that I've had this question up here in multiple SWYKs, and we'll continue. Part of the reason is because I drew a couple other questions from other textbooks inside the Math Excel program, and it does not like it if you don't use one of the problems from your current textbook. So I did that, and so that's why I'm repeating this one over and over again. Plus, it gives you good practice, right? -1, +5, +6. All you're doing is setting them equal to 0 and solving just like we did in the previous video. Now, in question 2, we are looking at something that has it asks, find the x-intercepts of the polynomial function. Okay, that means we need to factor it. State whether the graph crosses the x-axis or touches the x-axis and turns around. You know, idea of cutting through or bouncing. So first thing I did was I looked for, well, I guess we can look at the leading term, 1x to the 4th. Since the leading coefficient is a +1, that means the right-end behavior is up, right? That's the +1. Since the degree is even, then that means that the left-end behavior is the same as the right. Since the right was up, the left will be up also. We factored it, right? The first thing I did was I looked for a GCF of x squared, and I pulled that out. The remaining part, I needed to come up with factors of -33, whose difference was +8. So I had x plus 11 and x minus 3. So now I know that my zeros, did I write this down? No, I did not. I know that my zeros are -11, 0 itself, and +3. Okay, you'll notice that I put the blue dots on the x-axis. These are estimates. This is just a sketch. It doesn't need to be a perfect graph or anything like that. We know we attach our end behavior on the graph, right? We've got both going up. Well, the even multiplicity occurs at 0. So this is odd, so it cuts through. This bounces, and then this cuts through again, creating that shape. If you go through the multiple choice answers, of course you get rid of something that says that 11 touches the x-axis and turns around, because that's not true. It doesn't even happen at 11. All right, it's occurring at -11. All right. Also down here you can see that they used 11 and -3, which are exactly opposite. And of course here it says 0 crosses the x-axis, which we know it doesn't. It bounces. The only one left is choice D, which has all of the necessary points. So in a lot of these examples that we're doing, I do more than you typically need, because I'm trying to show you all of the pieces of information. For instance, when I look at this, if you want to know the leading term, you take the first, you got -x squared times x squared. And that gives you -x to the 5th right here. And then you can from there determine that the right-hand behavior has to be down, right? Because of the -1 leading coefficient, and the odd degree says that the left has to be opposite of the right. I also noted right here that this one is a difference of perfect squares and can be factored further into x plus 1 and x minus 1. As I said, I do more in this question than you need in several of the other ones as well. You see that I made a table over here, and it's just to kind of help me organize my information. So, my -x squared over here, that created my 0. I have an actual x-intercept at 0. If you, take this, divide by -1, right? Set it -x squared equal to 0. Divide by -1, and take the square root. You still end up with 0, right? And that's where that comes from right there. It did have a multiplicity of 2 because it was occurring as a factor twice. All right, then you have -3, right? That only occurred as a factor once, and so the same is true with the x plus 1 and x minus 1, creating the 1 and the -1. So these were all cutting through the axis. This is the only one that bounces off the axis. All right, and so what I did was I came to my outermost zeros, attached the correct shape of the end behavior, and then cut through, bounce, cut through, cut through. That's the shape of this particular graph. Okay, and then if you go through your answer choices, you can see that the only one that matches is number 3. Sorry I'm moving quickly, but I have 8 different problems here just to kind of give you more and more of a feel of what's going on. Similar types of things, right? X squared times x, that gives me x to the 4th. The right-hand behavior would have to be up because the leading coefficient is positive 1. It's an even degree, so the left has to be the same, okay? Going through, it's already in factored form, so I've got 0, positive 6, and positive 3. You can see that the 0 has a multiplicity of 2 because its exponent is 2, and the others have multiplicity 1. So this one ricochets off the axis, and these two cut through the axis. And so the picture looks like this. You attach your end behavior to the outermost zeros, right? And then you realize where the bounce is, and it cuts through, and it cuts through. And then you can find the one that matches what you need in the multiple choice answers, ruling out ones that have bad x-intercepts or telling you to do the wrong thing. Question 5, similar type strategy, right? You can see I've got x minus 2 quantity squared, so that means the x-intercept 2 occurs twice, right? That's going to be your even multiplicity and it's bouncing off the axis. You can see the x squared minus 25 can be broken up into x plus 5 and x minus 5 because it's a difference of perfect squares, creating 5 and negative 5. They both occur as a factor once. If you take from the first parenthesis x squared times x squared, you end up with x to the 4th for the leading coefficient. I don't have to FOIL all that stuff to figure out what the leading term is. If you didn't know, I have said that in other videos, the leading term LT. So the leading coefficient is a positive 1, meaning the right-hand behavior goes up. The even degree tells me that the left is the same, so I attached my end behavior, probably need to use a different color, attached my end behavior to the outermost zeros, realized which one was doing the bouncing, the bounce happened at 2, and which one's cut through the axis, and then choose the correct choice which matches that idea. Quite honestly, I don't have to make a graph each time because I can probably get all this information from here, but I need you to kind of understand the visual of what's going on, so that's why I'm drawing the pictures just to kind of help with that whole learning process. On question 6, you can see that you have negative 3 times x cubed. Negative 3 times x cubed gives me negative 3x to the 4th. Being a negative 3 in the front means that my leading coefficient is telling me that the right is down. Being an even tells me the left is the same as the right. Okay, obviously if it was odd, it would be opposite of the right. I noticed that my multiplicities this time are 1. Now, for those of you who don't, x plus 3 halves equals 0. So solving that, I get negative 3 halves. It occurs as a factor 1 time, whereas the negative 3 occurs as a factor 3 times. Those are both odd multiplicities. What do I keep hitting the wrong button for? My apologies. So something weird's going on with this graph. I labeled the negative 3 halves. That's this one over here. It's negative 1.5, just in case you're wondering. And then you got negative 3 farther to the left of that one. Well, if they both cut through the axis, and we know that the end behaviors are both down, right? We got down and down. What's going on that's different? Well, I hesitate to do this, but it does do this little sneaky type thing as it goes through. Not that that's the most critical thing in the world. If you just drew it straight through, you would know that you're crossing the axis. So it's not that critical. I just thought I would show you. There is a slight difference in how it looks, but it's still crossing through at both of those locations, which is why letter D is the answer choice to this. Okay, both are odd, so both cut through the axis. Question 7 is asking you for a y-intercept. This is much easier than the previous questions. Every y-intercept in the universe has an x value of 0, so we simply plug in 0 for x. Well, that's going to knock out the first 2 terms, and it's going to leave me the last term, which is positive 8. Well, what about the next one? Question 8. It's in factored form. Does that make a difference? Absolutely not. You're still plugging in 0 for x. See now, most kids love, they look at this example on number 7 and they see it's the last number and they're like, oh yeah, that's great, that's easy, right? And so for some reason, when they get here, they go, oh, I don't know, maybe it's -1 because that's the last number. Okay, well, that's not what we did. We plugged in 0 for x. And if you plug in 0 for x here, 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 and then start simplifying it, you realize you get 1 times -6 times 1, which is -6, which is why answer choice B is the correct answer. And I think that's enough for this SWYK. Sorry, it went a little bit longer.